All right, guys, got a good introduction to logs yesterday. So we got some more logarithmic stuff, some basic stuff about them still, but more stuff you need to know. So let's hit this thing. This is evaluate with the calculator. Now, your calculator only knows base 10 and also base E. So what we're going to do here, if you find the log button, it's like 3 buttons above your on button on the calculator. On your 84, whatever you got, you just hit log and 45 and punch it in and just look at your number there. And usually with logs, they want you to go 4 decimal places. That's what I'm going to do here. And I'm assuming that's what they're going to want you in your book too. Almost every book I've ever seen goes 4 decimal places. 1.6532. You might want to punch it in while you're watching this and kind of make sure you're getting it. The next one's log 0.22. Just punch that straight into the same button. That's negative. I wonder why that's negative. Could it be that's a decimal and the base is 10 and to get decimal you'd have to flip the 10, therefore remember the answer to log is an exponent, meaning you'd have to get a negative exponent to get a decimal? I think so. And the last case is natural log 31. Natural log is 2 buttons above your own button. Just hit natural log 31, that's base E, and you should see this 3.43 40. Kind of a rounding mistake there almost. Now, one thing about that one, remember the base is E. E is about 2.71828. So what happens on that one is 2.7828 to the 3.4340 power would equal 31. That's why that is the answer. Remember, the answer to a log is an exponent. All right, change the base formula. We can trick your calculator into doing things that are not base 10. Like if you look at the example I have right here, it says log base 3 of 24. By doing this right here, we're going to take log base A of B, and what you can do is you can change it to any base you want to. Obviously, we want to do base 10 usually because that's what the calculator knows. By just doing log of the big number, the B, over log of the base always goes on the bottom. So when I'm looking at 24, this one right here, the one I have in the example, I'd rewrite it like this: log of 24 divided by log 3. Now, when you punch that in your calculator, which I'm doing now, you must close your parentheses around the 24. The biggest mistake I'll see people making, the only way you can miss it really is not to close it, because when you hit your calculator, you hit your log button, it's going to open one for you. Hit 24, close it, then punch in log 3. So I'm going to divide it by log 3, hitting enter, and you get 2.8928. You might want to do, I'm telling you, it'd be a great video to just kind of work through these problems as I go through it to make sure that you're getting the same thing. Now, the cool thing about this, you can change, remember I said you can change this to any base. It's called the change of base formula, which means you can also change it to base or use ln instead of log. So if you were to punch in natural log 24 over natural log 3, you would get exactly the same answer, which is pretty cool. Change of base, any base you want to, it will work. All right, last slide. Graph y equals log base 3 of x minus 2. We talked a little bit in class yesterday, or today, depending when you're watching this, about graphing just regular logs. Now this one has a -2, which means it's been shifted 2 to the right because the 2 is inside. That's a fact that you should know very well by now. So yesterday we had asymptote right at the y-axis. Now my asymptote's been shifted 2 to the right, just like this. You know, we almost always put our first point right there, 1 away, because 3 to the 0 power is 1. So I'm not sure why I just said that, but that point right there, think about this. If you put in 3 for x, which I'm doing right there, that would give me an x spot. If you work out 3 minus 2, that would be 1, and 3 to the 0 power would be 1. So that's why that point will always work. And this has been shifted up or down. All right, to get my second point, I want my parentheses to be exactly the same as my base. Well, my base is 3. So I want my parentheses to equal 3. So what I'm going to do to make that equal 3 is I'm going to put a 5 where the x is. So I'm putting 5 in for x. Don't forget that. That's my x. And when I work that out, I get this, log base 3, 3, which you know from yesterday, that equals 1. So what happened, I just then plugged in 5 for x. I got 1 for y. So I'm going to go to the point 5, 1, right there. And then I can just draw my graph. Connect the dots, la, la, la. So it's the same kind of graph you saw yesterday. The only difference being it got shifted 2 to the right. And you're going to have to describe that too. They're probably going to ask you, what happened to the original graph? And you say, it got shifted 2 to the right. And then graph it also. Okay, so not a bad day overall. Just a few more things to wrap up with general log info for you. And we'll work on it in class like we always do. See you tomorrow. See you, bye.